Let's investigate how to find the volume of a solid using the disk method. Let's look at the specific example of the region bounded by y equals 4 minus x squared and the x and y axes. Here's the x-axis, here's the y-axis, and y equals 4 minus x squared is an upside-down parabola shifted up by 4. So the region we're looking at is this little space right here. The y-intercept is 0, 4, and the x-intercept is 2, 0. And we're going to take this region and we're going to revolve it around the x-axis. Revolve about the x-axis. And when we do that, comes down here, and what we get is this three-dimensional solid that looks kind of like a sideways bowl. And we want to find the volume of this sideways bowl. Let's make a little bit more space here. Now what we're going to do is we're going to take a slice out of this bowl. So imagine we have this three-dimensional sideways bowl, and we take a knife and we cut out a slice, and we remove this one slice. And let's see what this slice looks like. Take out this slice, and it's a circular shape with a teeny little bit of a thickness. We'll call that thickness delta x. And this is a disk. It's got some radius, and the volume of this disk is pi r squared delta x. It's like a teeny tiny flat little cylinder, and so the volume of a cylinder is pi r squared h. This is pi r squared delta x. Now looking back at the original diagram, you see where this disk came from, and you'll notice that the r is exactly the y value. So the volume of our one little slice is pi y squared delta x, or if we want to put everything in terms of x, it's pi times 4 minus x squared squared delta x. So each little slice has the volume of pi times 4 minus x squared all squared times delta x. And now what we want to do is imagine all of the many different slices. Let's go to a new slide. So let's add up all of the slices. What we get is the sum of pi times 4 minus x squared all squared times delta x. And if I want to get not an approximation to the volume, but the actual volume, then I want to take the limit as those slices get thinner and thinner and thinner and thinner, and we have more and more and more slices. So that's the limit as delta x goes to 0. And if I take the limit as delta x goes to 0 of the sum, this should remind you exactly of the form of a Riemann sum. And this is equal to the integral of pi times 4 minus x squared squared, and the delta x becomes a dx, and we have to put limits of integration here. And remember on slide number 1 we had x was going from 0 to 2, and now we can put that right into the calculator, or you could do this by hand as well. Pull out the pi, integral from 0 to 2. If you square out 4 minus x squared all squared, you'll get 16 minus 8x plus x to the 4th dx, and you can take the antiderivative and plug in the 2 and then plug in the 0, or you can use your calculator and you can use the math frac feature of your calculator to get an exact answer, and you should get 256 pi over 15. Try it on your calculator and make sure you can get that same answer.